Well, good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here's another video here. Today we are doing how to determine the molar mass of a compound, worksheet number 2. All right. So without further ado, let's get moving on and let's see how far we go on this here. So I'm going to read through a few things here, some examples, and then we will do probably, I think, 14 examples of molar mass determination using the periodic table. Okay, so here we go. A definition of the molar mass. The molar mass, as the name suggests, is the mass in grams of 1 mole of a formula unit. It can be either an element or a compound. Rules for determining the molar mass. Number 1, the formula must be the formula must, let's try that again, folks. The formula must first be determined whether it is an element or a compound, binary covalent or ionic compound. The formula will indicate the number of atoms of each element. Using the periodic table and the molar mass of each element, multiply the molar mass by the number of atoms for that particular element. This will be the total mass of that particular element. If there are multiple elements, sum the total mass of each element. Round the final answer using the least number of decimal places from the molar masses that are on the periodic table. Add the units, grams per mole. Add the formula next. Here are some example problems so that you get it correctly. So let me scroll this up here so we can do some of these example problems. Okay. All right. So determine the molar mass of the element iron. Find iron on the periodic table. The formula is Fe. So I'm going to be using this particular periodic table here. And we're going to find iron on the periodic table. I'm going to highlight it here for you so that you can clearly see it. It is element number 26. The formula is Fe. The name is iron. And the molar mass for that element is right here, and it will be highlighted in the blue, and that's 55.85. All right, that's how we're finding that for iron, the molar mass. Typically, at a minimum, 2 numbers for each element on the periodic table. The molar mass is the number that is not a whole number, but a number with decimal places. Iron's molar mass is 55.85, correctly written as 55.85 grams per mole Fe. So I have a number, units, and a formula. Okay, so the number is right here. That's the 55.85. The units are grams per mole, and the formula is Fe. All right, let's see if we can do example B. Determine the molar mass of the compound carbon monoxide. That's CO. Carbon's molar mass is 12.011. There is 1 atom of carbon to give 1 times 12.011, which equals 12.011. Hopefully that math is super simple. Okay. And oxygen's molar mass is 16. There is 1 atom of oxygen to give 1 times 16 equals 16.00. Summing both, 12.011 plus 16.00 equals 28.011. And then we're going to round this to 2 decimal places because there's the fewest number of decimal places. So let's find carbon and oxygen on the periodic table. Here is carbon. It is atomic number 6. Here is oxygen. It is atomic number 8. That's carbon. That's oxygen. And the molar mass for carbon is 12.01 and oxygen is 16.00. Okay. All right, fantastic. And that's why this number has 2 decimal places. Again, it has the rounded answer correctly to 2 decimal places. It has units of grams per mole and then the formula, and that's CO. All right, I'm going to scroll this on up and then we're going to do a few more examples here. Okay, this next example here is determine the molar mass of the compound dinitrogen pentoxide, N2O5. Okay, And nitrogen's molar mass is 14.0, actually 0.7 on this periodic table that I used. On the periodic table that I'm using today, it's 14.01. It's actually rounded. Okay, there are two atoms of nitrogen, and that gives us 14.028 0.02. Oxygen's molar mass is 16.00. There are 5 atoms of oxygen to get 5 times 16. That's 80.00. We're going to sum up these both. We're going to round this to the fewest number of decimal places, which is 2. And I'll show you that on this new periodic table that I'm using here. We have nitrogen. Its atomic number 7. That's an N, and it's nitrogen. Its molar mass on this periodic table is 14.01. It's really important that you use the particular periodic table that your instructor is giving you, because the molar masses for elements do vary on the periodic table. They are to different precision. So this is rounded to 2 decimal places. It has units of grams per mole, and then the formula unit of N2O5. All right, let's do another example. Determine the molar mass of the compound calcium nitrate. There's CaNO3 parentheses and a 2. So just to make sure here, this is a very, very important point here. I'm hoping that you see this 2 right here. It is outside the parentheses. So that 2 is outside the parentheses. So just like in a math class, we're going to distribute that 2 over both the terms. So that would be 1 calcium. That's why there's 1 calcium. There are 2 nitrogens, and 2 times 3, that's 6 oxygen. So making sure that you've got that correct there, you're going to distribute that number outside the parentheses. Once you do that, then you should see that you get this mass right here. It's rounded to 2 decimal places. The units are grams per mole, and then the formula unit CaNO3 parentheses and a 2. All right, perfect. So now what we're going to do is we are going to do 14 examples of molar mass calculations, which are on the back of this sheet of paper. So let's flip this over. But before we do, we're going to thank our sponsor. And our sponsor here today for today's video is none other than, that is correct, the Crazy Hat Chemist. I am your sponsor today. Please like, subscribe, and throw in a comment if you got questions. You can see that the comments are on fire right now. So send some more. All right, join the party. Okay, so here we go. We have 14 problems of which we are going to do. We're going to calculate the molar masses of these compounds here. And our first one is NO. No! Well, not really no, but it's nitrogen monoxide. So what we're going to do is we're going to come to our periodic table. We're going to find nitrogen and oxygen. So there's nitrogen right there. There's oxygen right there. Nitrogen is element number 7. Oxygen is element number 8. Okay, I'm going to zoom in on this so that we can zoom in and see each one of these in grave, wonderful detail. Okay. All right, fantastic. And so we're going to be using these elements here, nitrogen and oxygen. I'm going to highlight in blue the molar mass of both. Okay, so the question is how many nitrogens and how many oxygens? So the molar mass for nitrogen is 14.01. There is 1 nitrogen, so I'm going to multiply that by 1. Then for oxygen, the molar mass for oxygen is 16.00. I'm going to multiply that by 1. So there's 1 of those. I'm going to multiply, and then I'm going to add these up, and then I will get to 2 decimal places of which I will be rounding, and that will be 30.01 grams per mole of NO. Okay, and you can see this here on my calculator. Okay, so I'm going to clear this calculator here first. I'm going to do 1 times 14.01 plus 1 times 16.00. And I'm going to get 30.01. Hopefully you can see that right there. Perfect. All right, let's do the next problem here. The next problem is nitrogen dioxide. So how many nitrogens are in this? One. How many oxygens? Two. And I'm just going to highlight that too. There's two oxygens and one nitrogen. So we just used nitrogen on our periodic table. We're going to come back to that. Nitrogen's molar mass is 14.01. So that's 14.01. There's one nitrogen, so I'm going to multiply that by one. And then there are two oxygens, and the molar mass for oxygen is 16.00. 16.00. And then we are going to do the product and then get this in our calculator. So I'll show you that right here. So we have 1 times 14.01 plus 2 times 16.00, and we get 46.01. So we're going to write that. That will be 46.01. It's going to have two decimal places, and the units are grams per mole, and then the formula is NO2. Okay, so in all these problems, you're going to need a number rounded correctly, the units, grams per mole, and the formula unit, that's NO2. So number, units, formula. Don't forget about that, number, units, formula. Okay, the next one here, S is ethane, and that's C2H6, C2H6. So I'm going to find a new element here that I haven't done thus far, and that would be carbon. So carbon is atomic number 6. It is a C for carbon, the word carbon right there, of course. And the molar mass for one carbon atom is 12.01. So what we're going to do is 12.01 times how many carbons there are, and there are two of them. And then the next element that is new here is hydrogen. Hydrogen is over here. It's actually atomic number 1. It's the first element, atomic number 1. That's an H, that's hydrogen. And then the molar mass for hydrogen is 1.01. Okay, so that is 1.01, and there are 6 of these hydrogens. So we're going to multiply and then sum them up. So let's see if we can do that right here. Clear our calculator. I'm going to slide this on up just a little bit here. So it's 2 times 12.01 plus 6 times 1.01, and I'm going to get 30.08. All right, fantastic. So 30.08. Those are units of grams per mole, and the formula unit is C2H6. All right, fantastic. For ethane. Right. All right, so the next one here is propanol. That is problem number 4. So how many carbons are there? There's 3 carbons in this formula. How many oxygens? There's 1. And you have to be careful with this one here. How many hydrogens are there in this formula? Well, there's 7 plus this 1. So there's a total of 8 hydrogens. So we've done all these elements here from our periodic table, but we'll just briefly discuss them here. So there are going to be 3 carbons. Carbon is right here with a molar mass of 12.01, 12.01. And then hydrogen, there are 7 plus 1, that's 8 hydrogens. And the molar mass for hydrogen, atomic number 1, is 1.01. 1.01. And then there's 1 oxygen, and oxygen is atomic number 8. There it is right there. It's a molar mass of 16.00. 16.00. We're going to multiply and then add them up, and we'll get our correct answer here. Let's put this in the screen here, and we got 3 times 12.01 plus 8 times 1.01 plus 1 times 16.00. We're going to get 60.11. That's 60.11 grams per mole C3H7OH. That's isopropanol, propanol. Yeah, there we go. Perfect. All right, so the next one is problem number 5. Problem number 5 is KCl, that's potassium chloride. So we're going to find potassium on our periodic table. That is atomic number 19. That's a K for potassium. And the molar mass for potassium is 39.10. 39.10. So how many potassiums? 1. So 39.10, and there's 1 potassium. Then chlorines, there's 1 chlorine, and we need to find the molar mass for chlorine. Chlorine is atomic number 17. It's CO, that's chlorine. Its mass is 35.45. So 35.45, 35.45. All right, and let's key this into our calculator here. For potassium chloride, that's 1 times 39.10 plus 1 times 35.45 equals, we got 74.55. All right, 74.55. The units are grams per mole, and the formula is KCl. Again, number, units, formula. Perfect. The next one here is problem number 6. This is MgI2, which is magnesium iodide. Magnesium iodide. Okay, so magnesium, let's find that element on the periodic table. It is element number 12, magnesium, and it has a molar mass of 24.31. So 24.31 for the molar mass of magnesium. Let's write that down. 1 times 24.31 for the molar mass of magnesium. You can see that iodine has 2 of these elements within this formula unit. So it's 2 times the molar mass for iodine. Let's find iodine. It's in the same column as chlorine. That's a halogen. It's atomic number 53. That's I for iodine. And its mass for iodine is 126.90. So 126.90. Again, we're going to be doing the same thing on all these problems here, and that is 1 times 24.31 plus 2 times 126.90. So let's show that in the calculator. That's 1 times 24.31 plus 2 times 126.90. And I get the number 278.11. 278.11 grams per mole of MgI2. Perfect. All right. The next one is going to be aluminum oxide, and I'm going to highlight that we have 2 aluminums and 3 oxygens. Aluminum oxide. We need to find aluminum on our periodic table. It is lucky number 13. That's atomic number 13. That's Al for aluminum. What is the molar mass for aluminum? That is 26.98. So there are 2 aluminums at 26.98. And then 3 oxygens, and we have done oxygen before a couple of times. It's atomic number 8. That's O for oxygen, and it's 16.00 for its molar mass. 16.00. And then we're going to add these up after we type this into our calculator. So let's get this in our calculator. We have 2 times 26.98 plus 3 times 16.00. That will equal 101.96. 101.96 grams per mole of aluminum oxide. All right, fantastic. Okay, we are halfway done. We have just finished problem number 7. Okay, and we are going to move on to problem number 8. But before I do that, we need to thank our sponsor here today. And who is that? That is me. Me, myself, and I. That is the Crazy Hat Chemist. And I wish you to like and subscribe to my YouTube videos, and I greatly appreciate that. So thank you very much for that. Okay, here we go. We're going to do the second half of this worksheet. There is one critical problem here at the end. And I'm going to show you just one little thing about that one. So here we go. This next one is zinc sulfate. Zinc sulfate for number 8. So we're going to find zinc on our periodic table. It is atomic number 30. That's Zn for zinc. The molar mass for zinc is 65.39. 65.39. How many zincs are there? There's 1. So 1 times 65.39. And then sulfur. I need to find sulfur on our periodic table. And here is sulfur. It is atomic number 16. That's an S for sulfur. And the molar mass for sulfur is 32.07. One sulfur, 32.07 for sulfur. Then there are 4 oxygens, and we've done the molar mass for oxygen a few times. We'll do it some more as well. It is atomic number 8, O oxygen 16.00. 16.00. Excellent. We're going to key this into our calculator here, and you can watch this. So it's 1 times 65.39 plus 1 times 32.07 plus 4 times 16.00 equals, I get 161.46. So that's 161.46 grams per mole of zinc Zn sulfate, SO4. Excellent. Now we're done with that one. The next one is lithium oxide for problem number 9. So how many lithiums are there? There are 2 lithiums and 1 oxygen. We haven't done lithium. So it's right under here, under hydrogen, and that's atomic number 3, Li for lithium. There is lithium. The molar mass for lithium is 6.94. 6.94. So I have 2 lithiums at 6.94. And then oxygen, there's 1 of those, and we've done oxygen again, and it is atomic number 8, O for oxygen, that's 16.00. 16.00. Okay, and let's key this into the calculator as well, scrolling this on up here a bit. And I got 2 times 6.94 plus 1 times 16.00, and I am going to get 29.88. So 29.88 grams per mole of lithium oxide. Awesome. That was number 9. Here we go with number 10. Number 10 is ammonium nitrate. So we got to be careful about number 10. So what we're going to do is I'm going to highlight a nitrogen and another nitrogen. So the total number of nitrogens are 2. We've done nitrogen already before. It is atomic number 7. That's N for nitrogen, and it's 14.01 for the molar mass. There are 2 nitrogens at 14.01. Okay, for nitrogen. And then we have hydrogen, and there are 4 hydrogens. I'm going to circle that one. There are 4 hydrogens in ammonium nitrate. So hydrogen would be right here. Hydrogen atomic number 1, hydrogen 1.01. There are 4 of those. 1.01 for hydrogen, and then oxygen, there are 3 oxygens. That's 3 times the oxygen's molar mass at, where did that go? Gets that, hopefully, let's get that in focus. There we go. 16.00 for oxygen. 16.00 for oxygen. All right. So let's key this into the calculator here. You can watch this here on the screen as well. Awesome. And so we're going to 2 times 14.01 plus 4 times 1.01 plus 3 times 16.00. We're going to get 80.06. 80.06 grams per mole of NH4NO3. That's ammonium nitrate, a fantastic fertilizer. All right, the next one is problem number 11, and that is ferrous hydroxide. So I'm going to highlight something here, and that is this has parentheses in it and a number outside the parentheses. So we need to distribute this 2 over both the terms that are inside. Okay, the parentheses. So there is an iron, there's an oxygen, and a hydrogen. How many irons? 1, it's outside the parentheses. How many oxygens? 2, because it's inside the parentheses, and the 2 distributes. How many hydrogens? 2, because it's inside the parentheses, and the 2 distributes. All right, so what we need to do is first find iron on our periodic table, and it is right here, element number 26, that's Fe, that's for iron. We did this at the front hand of this worksheet here with the definitions, and the molar mass for iron is 55.85. There's 1 iron in this formula, so it's 1 times 55.85. And then there's 2 oxygens, and we have done that again many times, and that's 16.00 for oxygen. As well as hydrogen, there are 2 of those, and we've done that as well. And hydrogen's molar mass is 1.01. Okay, so 1.01 for the molar mass of hydrogen. So let's see if we can key this into the calculator, and you can see what's happening on this one as well. Okay, for ferrous hydroxide. So that's 1 times 55.85 plus 2 times 16.00 plus 2 times 1.01. And I'm going to get the molar mass of 89.87 right there. So that's 89.87. The units are grams per mole, and it's FeOH2 for ferrous hydroxide. All right, the next one. Okay, the next one here, I'm going to use another color here. There are 2 irons, and this 3 that's highlighted here is going to be distributed amongst what's inside the parentheses. So how many irons are there? Well, there are 2 irons because it's outside. There's no parentheses around that. The molar mass for iron is right here, 55.85. So 55.85. And then sulfur, I need to find sulfur. We've used sulfur again. That's element number 16, sulfur, and that's 32.07. There are 3 sulfur, so 3 times 32.07. And then it's 3 times 4, that's 12 oxygens, that's 16.00. Okay, add these up. Let's see if we can show you this on our calculator. Okay, so what we've got here is 2 times 55.85 plus 3 times 32.07 plus 12 times 16.00. That's going to equal 399.91. 399.91 grams per mole of ferric sulfate. Okay, excellent. We got 2 more problems to do. Hang on, we are almost there. You're doing really well. Okay, the next one here is ammonium phosphate. Okay, and again here on this problem, we have a 3 outside the parentheses. That 3 will be distributed amongst the terms that are inside. So there are going to be 3 nitrogens, and 3 times 4, that's 12 hydrogens. There's 1 phosphorus and 4 oxygens. So there's 4 elements in this one here. So the nitrogen, we have done that before. So nitrogen, that's atomic number 7, N, and nitrogen 14.01. There are three nitrogens at 14.01. Then there are 3 times 4, that's 12 hydrogens. We're going to find the molar mass of hydrogen. That is 1.01 for hydrogen. 1.01 for hydrogen. And then there's 1 phosphorus. We haven't done phosphorus here today, so let's find that. That is element number 15. That's right here. That's a P. That's phosphorus. And the molar mass for phosphorus is 30.97. 30.97. There's 1 phosphorus at 30.97. And then there are 4 oxygens at 16.00. Let's just verify that for the oxygen. It's oxygen and it's 16.00. We've done oxygen a number of times here today. All right, so let's see if we can key this into our calculator here. And we've got 3 times 14.01 plus 12 times 1.01 plus 1 times 30.97 plus 4 times 16.00. And that's going to equal 149.12. 149.12 grams per mole of ammonium phosphate. Okay, perfect. All right, the very, very last problem here, and there's just a little bit of a turn and a twist on this problem, so I want to make sure that you're really, truly paying attention. I really haven't covered it a whole lot on this worksheet, but there is a turn and a twist. So pay attention to this. There are most certainly parentheses on this problem here. That's right there. Okay. And then there is this 2 outside the parentheses, and that distributes over both the terms inside. This is plumbus or lead 2 nitrate. There's 1 lead. There's 2 nitrogens, and 2 times 3, that's 6 oxygens. Okay, so let's slide this up on over here. And there we go. So we're going to find lead on our periodic table. There is 1 lead, and lead is right here, element number 82. There it is. There's element number 82. That's Pb for lead, and the molar mass for lead is 207.2. I want you to notice something here. And I'm going to just circle this in red. 207.2. This is very unusual here. There are not very many elements that have such low precision, but lead has a very low precision of 1 decimal place. Most of the elements on my periodic table that I've been using has 2 decimal places. So lead has 1 decimal place. Okay, so 207.2. We've done nitrogen here, and there are 2 nitrogens, and nitrogen is 14.01. That's 14.01, and there are 2 times 3, that's 6 oxygens, and that is 6 oxygens at 16.00 each. 16.00 each. Okay. I'm just going to highlight that again, lead has to 1 decimal place. So we're going to take advantage of that here, of that little quirky thing in just a moment. So here we go in our calculator. What do we have? 1 times 207.2 plus 2 times 14.01 plus 6 times 16.00. What do we get? 331.22. That's in my calculator. So we're going to write that number down, 331.22. One of the rules here on determining molar mass, your last operation here is addition. We actually multiply first and then we add. When we add and we're using significant figures, we use the least precise measurement, which is always the one with the fewest number of decimal places. So 1 decimal place, that means I need to have my answer to 1 decimal place, and I'm rounding with that too. That is less than 5, so I'm going to chop or truncate the number. So I'm going to have 331.2 grams per mole of plumbous nitrate. Okay, fantastic. That one is the very last problem. Notice that it's to 1 decimal place because it had the lead in it, which was one of the least precise elements on our periodic table. I'm the Crazy Hat Chemist, and that was a fantastic video on determining molar masses of compounds, and hopefully that worked out well for you. I hope you have a fantastic morning, afternoon, and evening, and I will see you next time for more cool, crazy videos. Talk to you later. Bye for now.